to summarize chapter 4. So we will do impact, and then another one is the flow inside the pipe. All right. So now we look at impact. Impact. So what is impact? Basically, is two objects meet together, right, and then create some collision, right? So this one you can read. One specific technical word that we use is impulse. You will be learning what is impulse in 4.4 section. There are two types of impact here. So one is central impact, and another one is oblique impact. As you can see in your tutorial handouts there, you'll be seeing two diagrams. This one. So what mean by central impact? The rest you can read on the slides. So central impact is that the two objects here, A and B, they meet at horizontal straight line. Okay. So when two objects meet, right? So object A, object B, both come with velocity VA, means velocity of A. B come with velocity of B, and then when they collide, when two objects meet together, you have two new terms here. One is the plane that they meet, right? The plane that they meet. You imagine there's an A4 paper between the two objects. There's a two A4 paper between the two objects. Let me find a piece of paper. So basically, the A4 paper here, right? The A4 paper here is your plane of contact, right? The A4 paper here, when my these two objects here, my hand, my fist is two objects A and B. So the A4 paper is the plane of contact. Another one is line of impact. Line of impact, for central impact, both A and B travel in the same line. Okay, travel in the same line. So this is the characteristics or how you differentiate the two types of central impact. So each one of it will give you different set of equations. The most simplest one is central impact, and the one is oblique. For your info, one question will come out from here in your final exam. This section, 25 marks. Do you have 4 questions in your final exam? One question will be from this section. All right. Next, we look at oblique. Oblique is two objects meeting each other at one point, but the origin direction is a little bit different from the central. The oblique impact, both of them come with a certain angle referring to line of impact. So it can be from the top, it can from the left or right, but they will be an angle from the line of impact. Okay, so there's an angle. For example, A come with a vector velocity VA, and they measure from the line of impact. Right? Line of impact, theta. Line of impact. This one is theta 1, theta 2, or they are different angle. So as long as one of the member they come with an angle, it fall under oblique. And if two members meet together in a straight line, in the line of impact, they fall under central impact. Okay. Before I go into detail, these are the two types of impact you have. Okay. And then the type of question that you will see in the test or exam is to ask you to estimate what is the direction of impact after both of them collide. What will be the direction of A will go, B will go, and what is the angle of velocity and so on. Right? So this will be the objective of section 4 when you study about impact. Okay, I hope everyone clear. We have two types of impact here, central and oblique. Okay. All right. Let's look at central impact. So central impact, when you before the impact, we can break the sequence, can break the motion into a few sequence. We look at central impact first. Means that both objects meet along the line of impact. So let's look at the mechanism. So before impact, let's say you have two objects on the screen here. Object A, object B, both come with a different velocity, VA and VB. All right, before impact, VA and VB. How two objects will collide? Something must be slower, something must be faster, right? If this one, if object B is faster than A, then A will not catch up with B. So no collision happen, right? So in this case, because we are studying about impact, something must be slower. So speed of A or velocity of A must be faster than B before impact. This is the requirement. It's a requirement, just take note. Before impact, one of the object must move faster, right, in this sequence. But both, if this one come by opposite direction, then doesn't matter, right? But if you have two objects that chasing each other, then one of the object must be moved faster than another one. Okay, different setting, different setting. But what is important for central impact is that both of them move along the line of impact. Both of them move in the same straight line. Okay, then that one fall under central impact. So once you understand the velocity is different, A faster than B, so that collision can happen, this before, then how you write the speed? How you write the speed? Before, we always use the subnode of 1. So if you're referring to object A, you write V sub A 1. You don't need to follow the bracket, but as long as you label as 1. In your answer also, in your test or final exam, you must label clearly. Don't straight away give me answer. You must start with the general equation, then you start solving, start substituting. All right. So VA1, VB1. So this is represent before. And then we actually, in the impact, we are looking at momentum. Okay. We use momentum in our calculation. How do you calculate momentum? Mass multiplied by velocity, or MV. MV. Right. So momentum is very important for engineering dynamics. MV. So we calculate the momentum for A, momentum for B. This is before impact. Then, when they meet together, before impact or initial states, after a certain of time, A will catch up with B. Okay, A will catch up with B. Then you see this diagram. So when A catch up with B, right? A kiss B, right? A kiss B, so they will meet together, and deformation will happen. Meaning, you imagine as two objects as an elastic object, like a two ball, right? They meet together and they will squeeze, like somehow squeeze together. Right? This is a deformation of impulse. So both of them will squeeze, and then you have impulse. Right? So A will experience this one, B will experience this one. Right? So we already discussed this kind of phenomena in the previous lecture, where we look at the tutorial question before we come into impact. So effect, this is the this line here. This is effect of A on B. This one means if we have two objects, right? Two objects hit. Let's say this is A, this is B. So when two objects meet, right? What happened to your A? There will be impulse acting on A, right? However, if you look at this line, so this one arrow pointing to B means it's an effect on B, and if the arrow is pointing to A, means it's effect on A. Look carefully. These two will not be the same. and read carefully in the test or final exam. They might be a question asks you, calculate or determine the effect of A on B. Don't calculate this one. Look carefully, make sure you understand what is something on something. Don't confuse. It's a different arrow here. On the left hand side, this arrow is focused on B. Right hand side arrow is focusing on A. Each one is different meaning. Look carefully the question in the test or final exam. Look carefully. Just look carefully whether the question asks you the effect on B or effect on A. Don't confuse between these two. Okay. Once A catch up with B, you have deformation. And because of two objects meet together, you have impulse, right? So this is a deformation will happen. Okay. Next, after certain of time, A and B meet together, they will experience maximum deformation. During the maximum deformation, both object A and B will join together, or they will couple together and move in the same speed. Yeah. Before collision, both objects move different speed. Then one object catch up with one object, they will experience deformation impulse. After they join together, they will experience maximum deformation, where two objects will join together and move in the same direction. This setting is chasing case. It's a chasing case. When two objects meet head to head or opposite direction, they will experience the same deformation, impulse, and maximum deformation. Direction of velocity, it depends on the momentum they have before the collision, if head to head. So this one you already learn. There is an equation before impact. You already learn what happens if two bodies collide together and they move with the same speed. You already learn one equation for this one, the conservation of momentum. You already learned about this one. Okay, now once they meet together, they have a maximum deformation and move in the same speed. Okay, what happened after they deform and move at the same speed? There will be a restitution impulse. Means because of the mechanism of the particles, after they squeeze together, they will try to move in opposite direction. Okay. Maximum deformation, then they like a sponge, like a spring effect, they will return to their original shape. The state or the scenario of returning from maximum deformation we call restitution impulse or restitution process, where they return to their original shape. There are two scenarios, either return or permanently deform, meaning it will stay in this shape. After maximum deformation, there are two scenarios. Either they, like a spring case, they will return to their original shape, or they permanently deform. If the energy too large, then the particle will break, but that one fall outside our module. There is another chapter for that. What happens if the object destroyed after maximum impact, right? But in our case, our object doesn't destroy, but can either stay original shape, return to its original shape, or permanently deform. Still, they are experiencing the impulse, because once they maximum deform, they will continue. They will try to consume the energy, and then they will either fall apart or continue with the deformation. Okay, so there are two different notation here. After deformation, we use R for the force, for the restitution forces. We integrate force. What is impulse again? Impulse, what is impulse? Impulse is force multiplied by time. Again, what is momentum? Momentum is m multiplied by velocity, mv. What is impulse? Impulse is force multiplied by time, but in this case, your force we label as R, R to represent restitution. What happened before this one? We use P here. Before the maximum deformation, we use integration of P dt, still force, but we want to separate deformation impulse and restitution impulse. There are two different impulses here. Take note in your handouts there. Before maximum deformation, we use P to separate the before and after. Before maximum deformation is under deformation impulse, we use P. After maximum deformation, we use R to represent restitution force. Okay. So in practical, the impulse before the maximum deformation, the P integration of P dt before deformation should be larger than restitution. That's why I put a red box here in practical. In the real life, in the real life, all right. Sometimes in the module, sometimes we will assume this when we use conservation of energy or conservation of impulse, linear impulse and momentum, then we will assume before and after will be the same. There's no loss of energy, theoretically. If you use conservation of linear impulse and momentum, then P will equal to R in our calculation. But just take note, after you graduate, you go to and calculate a practical case, bear in mind that P and R is not the same value. P will always larger because it's happened before, so the energy is still there. Then after the deformation, then R will be smaller than the P. Then after restitution, again, what happened to restitution phase? Restitution phase, there are two possible cases. Either the object returning to their original shape, or stay at their permanent maximum deformation shape. There are two scenarios. Then after that, after impulse, we will have under central impact. Move after the separation from restitution, both objects will move in a straight line. And velocity of B will faster than A for separation. Okay. So VB2, 2 means after, will be larger than the VA2. And then the momentum will be different. MV, right? So momentum of B will be larger than A after restitution because of velocity. Velocity A and B. Velocity B will be larger. And we assume there's no loss of mass in our calculation. So there's one word called final momenta, means after impact, what happened? Normally for central impact, they will split away, right? So let's recap. So for central impact, this case is chasing case. So when chasing case, velocity will be different before the impact. All right. To have collision, one of the object must be faster or one of the object must be slower so that they can catch up. Then when they meet, they will have a deformation happen, deformation impulse happen. Then they will squeeze together and move in the same speed. We call it the state called maximum deformation. After maximum deformation, they will come into the state called restitution phase. So restitution means the impulse inside is changing. And after restitution, they will split to a direction, right? To a same, moving in the same direction. However, velocity is different. Okay, this is happened in a central impact with chasing case. What happened if we have two objects collide head to head? It was still the same scenario. However, head to head, the velocity, it can be the same, it can be different. So you will experience the deformation impact also. Maximum deformation, this one. If head to head, you are still same. When head to head, deformation, maximum deformation, move in the same speed, either left or right. Right? It depends on the which carry the highest momentum. So highest momentum will win. So you decide the direction. This one you can calculate with the conservation of momentum. Then after that, you will experience restitution. After head to head, so one of it will move faster after the impact. Okay, you still have the same final momenta situation for head to head scenario compared to chasing case. Any question for central impact? Any question?
No, sir.
Okay. Just to check, I'll ask one question. Vinod, are you there? Calling for Vinod.
Yes, sir.
Okay, Vinod, can you tell what is the difference between restitution and deformation? What's the difference between P and R? What do you understand about deformation P, deformation impulse using P and restitution R? What is their difference? What do you understand about these two states? Vinod, I cannot hear you.
Well, in restitution body it retains shapes. Deformation body like get destroyed.
Repeat your answer. What do you mean?
So in restitution body like it retains shape. Deformation body like it gets destroyed.
Repeat again your question.
Body gets collision.
Body get collision. Okay.
So in deformation body like it gets destroyed.
Get what?
Destroyed.
Do you see this object destroyed here? Do I mention destroyed during the class? Do the object destroyed? You understand what is the meaning of destroyed, right?
It's deformed.
Yeah. Okay. We use deform rather than destroyed. Destroyed is another chapter already. Means there's changing of energy. It changed from mechanical to potential to chemical to heat energy and so on. It's going to be a very complicated if you use destroyed. Okay. Next, we move to explain the okay, so most of the impact question, you'll be given the initial velocity before they collide. So you need to determine the final velocity for the two objects, right? Means something to something to, means after velocity or final momenta, right? So momentum for the system of particles is conserved. So in our calculation, we assume that the momentum is conserved during collision. So internal impulse deformation and restoration is cancelled. Okay, so we apply the conservation of momentum over here during our calculation. So the question that I asked Vinox just now, the internal impulse, the impulse for deformation, impulse for restoration, restitution, they cancel each other. Okay, initial momenta before impact, or we call it initial momenta. We have two different momentum, and after momentum, final momenta, you have after impact, the velocity also change. So by using the conservation of momentum, we can write the equation like this. But we already covered conservation of momentum in previous lecture. We just apply what we learned before equal to after. We are talking about conservation of momentum. So only momentum is calculated. So what is momentum? mv. So we have two objects, momentum 1, momentum 1. So momentum A, momentum B before impact. So MA1, MB, V1. After, we use 2 to represent after. Direction, we assume to the right will be positive. Okay. So start from, I think from chapter 4, you'll start seeing we are using direction in our calculation because direction is important in momentum and impact. So to the right is positive. So start practicing giving direction in your answer. Right? To the right is this one. So to obtain the second here, you need to solve A and B, right? So normally VA1, VB1 will be given. So you need to solve for V2, VA2, VB2. However, this you have two unknown. Two unknown, one equation you cannot solve. So you need one more equation to help you to find VA and VB. How you find? You use principle of impulse and momentum for each particle. So to find VA and VB later, you need to look at individual object by using principle of impulse and momentum that we learned before this. All right, you focus on individual particles. Okay, so let's look at particle A during the deformation phase. This one. Right, during the deformation phase, we look at A, what happened to A. So You have to understand which arrow is which. A, if you look at A, is this arrow and not another one. Don't confuse. A, what is the impact experienced by A, is this arrow. So you write what you learn in the principle and impulse momentum. Again, direction is important for impact. To the right is positive. We are focusing on A, and again, principle of impulse and momentum always use only on individual object. Take note of that. Don't confuse with conservation of momentum and principle of impulse and momentum. Principle of impulse and momentum, we apply on individual object only. That's why in the equation you see A, and impulse for the A. So if you write the principle of impulse and momentum, what you have? Momentum before plus impulse equal to momentum after. General equation is positive equal to positive. General equation, positive momentum plus positive impulse before, on the left hand side is before, equal to momentum after. Okay, here you can use VA2 if you want, but in this case, because after they deform, they will move together, right? So we will just use the diagram of here. Most of them move in the same velocity. That's why I use V here. Okay. Why negative? Why impulse negative? Because your impulse direction is pointing to the left. We're looking at A. We're looking at object A here. Your impulse is pointing to the left. There's a negative sign there. Right? And why P? P is before maximum deformation. So don't confuse. Later you will see R in one of the equations. Don't confuse. This is before deformation, or before they move in the same speed or spin, same velocity. So once you have this equation, this is from the conservation of momentum. You need to solve VA2, VB2. How you solve for these two, because this is a single equation, you have two unknown, you're not able to solve. You need the help of one more equation, which is we use principle of impulse and momentum. We use your focus on individual object. In this case, we focus on A. Of course, you can use B if you want. In this case, I use A as an example. So you write the equation for the principle of impulse and momentum for A. Here, you only have one missing parameter. I think you need to find for another one, because here you give you another final velocity here. Right? So just now is deformation with the P impulse, before deformation with the P impulse of P force there. What happened for A at the restitution phases? Restitution is after maximum deformation with the symbol R force. Same, you use the principle of impulse and momentum, but here your impulse is referring to the restitution phases, where in this case you use your R, which is this diagram. You're focusing on A. Which arrow pointing to the A? This one. This one pointing to the left. That's why in the equation you see negative sign there. And using R. In this case, on the left hand side is before, on the right hand side is after. In this case, your V for object A here is V, because it's after maximum deformation. What is the speed of object A? after maximum deformation, before they go into restitution, is v. So that's why velocity here is v, and it's not the VA1 or VA2, it's v, because we are referring to deformation. Okay, and after MAV2, they split after the impact, MAV2. So we have three equations here. One is equation of momentum. You have VA2, VB2, two unknown. And then just now we see what happened in the maximum before maximum deformation, where we have the deformation phase, where we have this equation. Second equation, and then we look at restitution. We have this equation. You have three equations, three unknown, right? You have the force of R and P will be given. So you can find your V, you can find your VA2 in the equation. So I copy these two equations. One is for deformation before the maximum deformation. This is before, this is after. So before maximum deformation is this equation. We use P. After maximum deformation, we use R to represent restitution phase. So basically, if you compare side by side, you have these two equations. So you can write, if you compare these two equations, you can develop one more new terms for today. We call coefficient of restitution. We use E. Coefficient of restitution means what is the ratio or what is the condition of the impact, or what is the change of the shape for the impact. It's given you by this equation. This is a new equation that you learn today. Coefficient of restitution E. You don't, okay, this is a new thing, not new thing, but it's a new terms for you, because you do not learn this one in your previous physics class, or you don't learn this one in your first year module, right? So E, your coefficient of restitution E equal to restitution impulse divided by deformation, or you can say as you take something before, after divided by before, output, input, right? Before divided by, after divided by before. Or you can see it as efficiency, output divided by input. Okay, restitution impulse, deformation impulse. It's a ratio. It tells you what happened to the change of form, the change of energy. Or it's a ratio between two impulses. Okay, you know the equation for these two, right? Restitution is this one. Deformation impulse is this one. You put these two together inside here. Normally, this value will be given. So you can find the ratio between P and R. Okay, you can find the ratio between P and R, or R over P. This one normally will be given. Right? Then you have this one. Okay. How you find this one? You rewrite this one. You pull this one. Okay. How you find impulse of this one? From here, you pull the whole thing to the right. You get positive integration R dt. If you pull this one to the right, then you pull this one to the left. Okay, You put this one to the left, you get MAV minus MAV A2. You put it on the top here. How you get the impulse for P here? Again, use this equation. Move this one to the right, you get positive again. Right, you want to change this negative to positive. How you do? Move this whole set to the right hand side, get positive. Move this one to the left, you get MAVA1 minus MAV equal to your deformation impulse. Right here. Why this equation? The mass is gone because mass A equal to mass A. So in front here, you cancel the MA. Okay, this is I move a bit faster. From here to here, I straight away give you the final equation. Any question on arriving at this one? Any question? Ask me now, or I will going to ask some of you or one of you to explain how you get this one. Good, huh? So you arrive at this equation by looking at these two equation of impulse and momentum. You rearrange, you get this one. This is something new for you guys. Coefficient of restitution, E. Okay, again, this one will come out in final exam. Okay, important. Again, this one you derive using the definition of coefficient of restitution before divided by after divided by after collision, not after collision, after maximum deformation divided by before deformation. Both look at impulse. Okay, coefficient of restitution, they focus on impulse. It's a ratio of impulse. How you get this information? From principle of impulse and momentum for A before maximum deformation and after maximum deformation. You calculate the ratio, you put in the term of velocity. Okay. So this is what you get for particle A. You can do the same for B. I will not go and repeat the same steps, but you arrive at the same procedure. However, for B, it will be different sequence of your VB2 minus V and divided by V minus VB1. Copy this one for B, this one for A. Okay, before a short break, I'm going to ask question. The question is, what is V? What is this V? Can you explain what is this V? I'm going to ask question. Prem, are you there?
Yes, sir.
Okay, Prem, from these two equations, can you explain what you understand about this term V? What is this V?
It was taken during the maximum deformation.
Okay, so what is that speed?
During the impact, the maximum velocity.
So what happened to A and B during this speed?
Momentum, the impulse will change.
Okay, what happened to A and B? Are they split together or what?
They will stick together.
Okay, they stick together. Okay, during this V, this velocity, A and B stick together. Right. So Okay, I've done with the question. So as long as you understand what is the rationale behind this equation, then you are fine. Important is that you understand what is E, coefficient of restitution E. What does it mean? Okay, then this is you derive from the impulse itself. Okay, these two equations will not be given in a final exam. You have to memorize it. Okay. Okay. So if the unknown V is eliminated from the two equations here, okay, if you eliminate, how you eliminate? This one equal to this one. So you take this one equal to this one, rearrange the equation, cancel out the V. You arrive at this one, right? You arrive at this final equation. So copy this one as your final equation for coefficient of restitution. E will be VB2 minus VA2 divided by VA1 minus VB1. So on the top, you take B minus A. Below, you take A minus B. Or how you memorize it, you always take the highest velocity minus the lower velocity. All right. So what happened to after the maximum deformation? B move faster than A, right? So you take B minus A. What happened before maximum deformation? A move faster than B. That's why you take VA minus VB. Okay, you can treat as a ratio of speed before and after, ratio of differences in speed or in velocity before and after. Okay, memorize this one because VA will be given. Okay, VA1 will be given, VB1 will be given, this value will be given. So you can find the ratio between VA2 and VB2. Take this one, substitute back into the equation. You can solve the missing VA2 and VB2, VBA2. Okay, we arrive at this equation. After break, we will look at one example. Okay, what else? Okay, this is what we explained just now. Yeah, this is a further explanation. So VB2 minus VA1, another textbook, they say this one as a relative velocity. It's a relative velocity, right? So relative after divided by before impact. Okay. Sometimes in test question, they ask you calculate the relative velocity after impact, meaning you need to find VB2 minus VA2. The question won't say so direct to find VA2 minus VA2. Sometimes the question will just state find the relative velocity after impact. It just means that find the differences between the first object and the second object after impact. Okay, yeah? Just take note of this one, the meaning of relative velocity. Or you can say a difference velocity. Two terms here. If your E, coefficient of restitution E equal to 1, it means you have the perfect elastic. What I mean by perfect elastic? It will go back to 100% of the shape after and before impact. Meaning this one will equal to this one, or this one equal to this one. That's why you get 1 for the restitution. So if your elastic impact is 1, if your coefficient of restitution is 1, it means that you're having a perfect elastic case. In real case, you won't have this case, right? Unless you created a perfect material that do not absorb energy or do not release energy, then you have elastic impact coefficient restitution equal to 1, right? In real case, you have less than 1. What I mean by plastic impact? When your coefficient you have equal to 0, okay, equal to 0. So after collision, they are stick together and move in a common velocity, right? So it can be between 0 to 1, this value. It can be between 0 and 1. Okay. Yeah. So just for info, there's a difference between what happens if your restitution equal to 0, what happens restitution equal to 1. Okay, so these are the keywords that you're looking into in the question. So sometimes you have it asks you to calculate the differences between perfect elastic case, where you will put E equal to 1 in your calculation, and you compare with the plastic impact, where you put 0 over here. Right, normally I won't give you 0 case. I'll give you some value more than 0, but less than 1. Okay, so if you have coupled and moved together, then you're having a plastic impact. Your deformation will be 0. Okay. How you get 0? You must be very good in fraction number. How this one, you put your 0. Okay. You don't put the wrong one. Put the wrong one, wrong position, you get infinity. All right. We stop here, then we continue after the short break. Yeah?